This is Scott Sharp doing some math. Today we're going to be looking at section 1.3 in geometry using the midpoint and distance formula. So first off, what is a midpoint? Sorry for all the noise there. Okay, what is a midpoint? A midpoint, you can guess, is you have 2 points on a line or a segment, and the midpoint, so let's call this A, call this B. The midpoint is the center of those 2 segments there, and it splits the segment in half into 2 equal pieces. And I'm going to use 2 tick marks to decide that these 2 segments are congruent. The segments I'm talking about is AM and BM. So the midpoint formula, let's go to the next page. How it works is the midpoint formula, if we have the coordinates x1, y1, so that's the first coordinate, and the second coordinate x2, y2, then our formula is we take our x's and add them together and then divide by 2. So it is the average of the x's and the average of the y's. And that'll give us our midpoint. So our midpoint is always in coordinates because we're looking for the location of the midpoint. Segment bisector. So we have a segment, and a segment bisector is something, so it could be a line, a ray, another segment, and it splits it in half so that one side is congruent to the other. And then the distance formula, you should remember this by algebra, but it's been a while. But what you do is you take the differences, the difference of your x's, so x2 minus x1, and then square it, and then do the same thing to your y's, and then put it all under the square root. So once again, let me rewrite this. x2 minus x1 squared plus y2 minus y1 squared. And that's all under the square root. Alright, let's do some examples. So my notes are a little bit incorrect, but point C is the bisector of segment BD. So remember, whenever you're labeling or naming something, always tell me what it is by whether it's a segment, put a bar on top, a line with arrowheads for a line. If it's a ray, then it has 1 arrowhead. Write an equation to find the value of x. So we know that point C is the midpoint because it's the bisector. Bisector means, so bi means 2. Sector means like sections. So parts, so biparts, so 2 parts, so 2 equal parts. So just to let you know, this 1 tick mark does not mean the middle. It just means that this is congruent to this. Okay. So if the segments are congruent, that means their distances are, or lengths are, equal. So 3x minus 2 is equal to 2x plus 3. So we're going to add 2 to both sides. And I will get, this is addition, because they want us to use a reason for each step. So this is 3x equals 2x plus 5. And then I'm going to subtract 2x over from both sides to get x equals 5. Okay, find the lengths of segment BC and CD. Are these segments congruent? So I'm going to grab, I know what x is equal to now, and now I'm going to plug them back in to our equation here, our equations. Let's see what we get. So for BC, so when we're looking for length, we don't put the bar above. So 3x, so 3 times 5 minus 2. So that's 15 minus 2, which is 13. And then over here, for CD, we have 2 times 5 plus 3. That is indeed 13. What is another name for point C? That is the midpoint. Example 2. So, before I move on to example 2, I want to use the midpoint formula. So I'm going to skip ahead just a little bit. There we go. So let me do another example first of what we just did. So K is the midpoint of JL here, and they want to find the length of KL. So I'm going to set JK equal to KL. So that means 8 minus 3x equals 2x plus 5. So I'm going to add 3x to both sides and get 8 equals 5x plus 5. Minus 5 to get 3 equals 5x, so x equals 3/5. So then they want to know KL, so KL, remember, is 2x minus 5, or plus 5. So I'm going to do 2 times 3 divided by 5 plus 5. So I'm going to get 6 over 5 plus 5. And that changes into 25 over 5. So up here, that is the length of KL. A little bit over 6. Okay, checkpoint 2. So the endpoints of CD is -8, -1, and 2, 4. Find the coordinates of the midpoint. So our midpoint formula, again, so if I was just looking for the x-coordinate, I would add my x-coordinates together and divide by 2. And that would give me my midpoint of my x-coordinate of my midpoint. So let's go find that really quick. So here's my x1, here's my x2. It doesn't matter which one you label, x2, x1, as long as you keep the other one the same. So -8 plus 2 divided by 2 is -6 divided by 2, which is -3. So that's my x-coordinate. My y-coordinate, add up your y's, and that'll give you your y midpoint. So -1 plus 4 divided by 2 is 3/2. So my answer is -3 and 1.5. Leave it as a fraction. Okay. So that's how you do it forward. So we have this formula here for the x's and that for the y. I wrote it differently up here because I wrote it as a coordinate, instead of 2 separate formulas. So let me go back to example 2 here. So the midpoint of JK is 3, 4. So they already give us the midpoint here. So if I was going to just draw any old line. Here's J and here's K. They already give us M. So they already give us M and they give us J, but we don't know what K is. So we're going to still use the same formula. So here's my X. But I'm going to fill in everything I know. So I know one of the X's is this one. So I'm going to put 1 plus, we don't know what the other one is, so I'm going to put X divided by 2. But we do know what the midpoint is. It's 3. Okay. Now I solve for X. I'm going to multiply both sides by 2 and get 1 plus X equals 6, so X equals 5. And then I'm going to do the same thing with the Y's. So I know what one of the Y's are, that's 6. So plus our other Y we don't know, divided by 2 equals 4. Multiply by both sides by 4, and I get 6 plus Y equals 8. And then I subtract 6 over, and I'll get Y equals 2. So my answer is 5, 2. Okay? So it's working a little bit backwards. So because they give us our midpoint coordinates, but they're missing our second coordinates, or second endpoint. While back in here, we had 2 endpoints, so we just add them together, divide by 2. And then this one, we're missing our second endpoint. All right. Example 3. Prove the distance formula given the Pythagorean theorem. So let's say I want to know the distance between here and, let's just say here. And if you don't know this, even though this is a geometry formula, you'll learn this later. You might have known this from just people talking about it on TV. It's the Pythagorean theorem, a squared plus b squared equals c squared. And what it basically says is, if you have a triangle, and if you know the distances, or the lengths of each side, so here's length A, length B, and length C for the longest side, a squared plus b squared would equal c squared. Now, how does that relate to the distance formula? Now, if you look at, so there's C there, so we're going to use the same C, but if you notice, if you remember from your algebra, how do I get rid of a square root? I square both sides, so I have C squared equals x2 minus x1 squared plus y2 minus y1 squared. But what does this mean, x2 minus x1 and y2 minus y1? If I have, let's say the 2 points again, so here's just redrawing it, C, and this one is x1, y1, and this one's x2, y2. Let me rewrite that. So here's point A, or there's B. So here's the value C. So this coordinate would be x1, y1. And this one would be x2, y2. So if I wanted to know this distance, that would be the differences of the x. So this is actually A, because this is x2 minus x1 here, this bottom one. And then B would be the differences in my heights, right? Or the height there. So I actually have c squared equals a squared plus b squared. So that's where the distance formula comes from. We'll definitely go over the Pythagorean theorem later. I forgot which chapter, but we'll eventually visit it. But there's the distance formula. I could have done it a different way, but I just didn't have enough space. Don't worry, you don't need to prove the distance formula. Just wanted you to know where it came from. Here we go. So checkpoint 3. So the midpoint of xz is m. One endpoint is -3, 7. Okay. So this time they give us the midpoint again. So I'm going to using the same formula here, but filling in what I know. So -3 plus x divided by 2 equals 5. And that'll give us multiply both sides by 2, so I'll get -3 plus x equals 10. So x equals 13. And then same thing here for my y's this time. So 7 plus y divided by 2 is -6. Multiply both sides by 2, and I'll get 7 plus y equals -12. Subtract 7 subtract 7 from both sides, and I'll get y equals -19. So my answer is 13, -19. All right, one more problem. What is the length? So this is not asking for midpoint, it's asking for length. So we're going to use the distance formula. So distance formula again is x2 minus x1 squared plus y2 minus y1 squared. So 5. So it doesn't matter which one you call your first coordinate or your second coordinate. Just make sure you label them so you don't get mixed up. So here's x1, y1, x2, y2. And then I'm going to plug them in. So x2 is -3 minus 5. Put that in parentheses, squared, plus y2, which is 6, minus -1. So double negative. And then that's all under the square root. -3 minus 5 is -8. That's going to be squared. Plus 6 minus -1 is +1. So that's going to be 7. So I get square root of 64 plus 49 equals the square root of 113. That cannot be simplified down anymore. It's actually prime. So that's all we can do. And that's it for 1.3. Have a good one.